Okay, so we're back, and this time we're going to talk about inverse variation. And inverse variation is different in that when we talk about inverse variation between two quantities, it means that as one quantity increases, the other one decreases proportionally. Or as one quantity decreases, the other one increases proportionally. And there's all kinds of situations where this occurs, right? But our usage is this. We say y varies directly as x, then we're going to use the model y equals k over x, right? This is our thought model for a relationship between y and x if they vary inversely. So at constant temperature, here's an example. At constant temperature, the pressure of a gas, P, varies inversely as the volume V of the gas. If the pressure of a certain gas is 75 pounds per square inch when the volume is 200 cubic inches, find the pressure when the volume is 450 cubic inches. Well, how are we going to work this? Well, in our particular situation, we say that pressure, P, varies inversely as volume, V. So if y varies inversely as x, or p varies inversely as v, then we're going to use this model that p is equal to some constant divided by v. Our job really is we're going to start off by finding that constant k by using the given information. And what information is that? Well, 75 pounds per square inch. 75 pounds per square inch is equal to whatever the constant is divided by our volume, and in this case that's 200 cubic inches. So what do? Well, in this case, to find K, we have to multiply both sides by 200. So let's multiply both sides by 200. 200 here, 200 here. And remember, it is in fact cubic inches that we're multiplying, cubic inches. Okay. So when we multiply that, let's see what happens. Well, of course, the 200 cubic inches and the 200 cubic inches here reduce out, leaving us with K. If you want to multiply 75 times 200, remember 75 times 2 is 150, and we have 3 zeros after that one. So if we work that out, 75 times 200 is going to be 15,000. 15,000. And of course, the inches cubed and inches squared cancel in a way that makes this look like the ratio pound inches, which is kind of an interesting unit, but okay, we'll go with it. So our proportion then is given as P is equal to 15,000 inch pounds, we'll call it. I'll just reverse the order of those, sounds better in alphabetical order, divided by V, volume. All right, so what does that mean? Well, let's find the pressure when the volume is 450 cubic inches. So we're going to take 15,000, good Lord, can't say it, inch pounds, and divide that by our volume of 450 cubic inches. All right, so that means we're going to have to reduce a little bit right here. Of course, we know that 150, both numbers end in 0, so we can divide out a 10 right away. And 15 and 45, I note, are both numbers that are divisible by 9. So let's try that. Let's divide by 9 to reduce the fraction. If we divide by 9, and if we divide by 9 in the numerator and denominator, let's see what happens right here. Well, in the denominator, 45 divided by 9 is 5. Is that going to work, 150? Actually, I'm not sure that it's divisible by 9. Let's try this. Let's see. What could they both be divisible by? I'm going to have to reduce my try right here. Let's say, well, both of them are definitely both divisible by 5. Divide by 5. So 1,500 divided by 5, what's that going to be? Well, that's 300. 45 divided by 5, well, that's 9, right? And by the way, when we take inches divided by inches cubed, that's inches squared, so we're left with pounds per square inch, which makes sense for a pressure. And it looks like this is divisible even further, right? 300 and 9 are both divisible by 3, so that makes this 100 divided by 3, which we could also write as 33.3 repeating pounds per square inch. So our pressure at 450 cubic inches is 33.3 repeating pounds per square inch.